Hey guys, so we're going to start 4.4, which is increasing and decreasing in functions, and the first derivative test for relative extrema. So here is the idea of what we're going to do. First, we're going to look at any domain restrictions. Then we are going to find all critical numbers. Remember, that's where your derivative equals 0 or is undefined. But let's keep in mind, domain restrictions cannot be critical numbers. So that's why we do our domain restrictions first. After that, we locate the critical numbers and domain restrictions on an F prime number line. So in other words, our sine ray, okay? We're gonna do our sine ray, and then what we are able to see is we are able to identify the intervals in which our graph would be increasing or decreasing, and then we would be able to identify the relative max or min, depending on increasing the decreasing or decreasing the increase. So we'll see how that works. One of the things we want to point out here is that a frequent area of confusion for students is the question of whether to include endpoints on intervals, okay? And you might have run into this with your secondary 3 teacher. Some textbooks would say the function y equals x squared is decreasing on the interval -infinity to infinity and increasing on 0 to infinity, okay? That's probably the way I taught it with the parentheses, right? Other textbooks would actually put the bracket there, using it as a closed interval. So the concept of increasing and decreasing is not based on a point, but an interval between here and here. So let's keep in mind that the definition of increasing is that x values increase, the y values increase. Same thing for derivative. Same thing for decreasing. As the x values increase, the y values decrease. So we're talking about an interval. The good thing is the College Board is aware of all of that stuff going on and will not penalize you for that, okay? Now, on a free response question, readers have been instructed to count either answer, so you don't have to worry about it. They will never list both open and closed options as a multiple choice, so luckily it's only one or the other. And it's more likely that multiple choice answers will be closed intervals, okay? So I know that's something you're not used to, but luckily they won't have one open and one closed, and you have to decide between the two. They'll never have that. The question whether to include 0 when listing where y equals x cubed, this one's x cubed, is increasing is completely separate question. All textbooks will say it's increasing on -infinity to infinity, even though the derivative is 0 at x equals 0. Any other answer would not receive credit. So keeping in mind that infinity and -infinity always have a parenthesis around it, okay? So that must be, they will not give you credit for a bracket around your infinities. All right, so let's follow those steps. There's the bell. Let's follow these steps for finding our intervals and our extrema, okay? So find the intervals on which the functions are increasing and decreasing, and find all local extrema. Remember, all local means your max and your min, your relative, okay? And it says here, and what's the points? So it's just not the x value, you're gonna have to plug back in for the y. All right, so first we need to see, are there any domain restrictions? As you can see right here, there's no problem with this whatsoever. Think of 2 over 3 as your exponent. Will have your kind of a rainbow from a point, okay? Now let's take our derivative. That's going to be our next move. When we take our derivative, we get 2/3 times x squared minus 9. Subtract that one, we get -1/3. Don't forget to multiply by the derivative of the inside, which is 2x. Now, what I'm going to do is put this in a simplified form so it's easier to tell where those critical numbers will be. So when I do that, I end up getting 4x all over 3 cube root of x squared minus 9. Okay. Critical numbers, right, is when your derivative equals 0. Okay. So where does our derivative equal 0? It's when our numerator equals 0. So what makes this 0? 4x equals 0 at x equals 0. Okay, those are our zeros. Now, what makes it undefined? Undefined really comes from our denominator, right? Because our denominator can't be 0. So what values of x here would make this 0? Well, we can't have 0 under here, so what multiplied by itself minus 9 is 0? That would be 3 and negative 3. All right, so now we're going to do our sine wave. What you want to do when you start doing sine waves, guys, is label what your sine wave means. So we're taking a sine wave of the first derivative, so I'm going to say f prime. I'm going to put my critical numbers or critical values, because sometimes I say values, in order. So I get negative 3, 0, and 3. And now I can do my sine wave. Negative, positive, 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 negative, negative, positive, positive, negative, 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 positive, and negative, negative. Wait, I only have 3 rows. Sorry. I don't have a row of negatives because I would only have a row of negatives if it was a negative function out front. Okay. Did too many rows. 3 numbers, 3 rows, works out well. Okay. Multiply straight down. Negative times a negative is a negative. This becomes a positive, a negative, and positive. Here's what's great. All the negatives is where it is decreasing. All the positives is where it's increasing. So let's write these down right now. Let's go increasing first. And I'm going to put them all on one line. So increasing, remember, it wants you to get in the habit of using brackets for your numbers, but don't worry, it won't mark you wrong with parentheses. So increasing from negative 3 to 0 and increasing from 3 to infinity. Okay, parenthesis around that infinity. Then we have our decreasing. So our decreasing is from negative infinity to negative 3 and 0 to 3. Now, when it comes to max and mins, what I like doing is actually drawing it out, because negative would mean I'm decreasing, positive increasing, negative decreasing, positive increasing. So now I can actually see that down here, this is a min, this is a max, and this is a min. You guys see how I like drawing that? So I'm just going to put it on the side. So relative mins we have at negative 3, and then I got to plug in, and also at 3. Now, where do you plug in? You plug into your original problem. So when we plug in 3 and negative 3 into our original problem, we actually get 0. And then our relative max is at 0. When we plug in 0, we do not have to write it all the way or calculate it into a decimal. I'm going to keep it as negative 9 to the 2/3. And we're done. I'm going to make space just because it looks like there's a lot going on here. All right, and then we do the same thing over and over and over. All right, so on number 2 here, of course, it limits, because on a unit circle, or even if we graph on an XY axis, it goes on forever. So let's just do a certain period of that graph or of that unit circle that once around. So are there any domain restrictions? No, because this is sine, right? There's no problems with sine. If it were tangent, we'd run into a situation. So next, let's take our derivative. We get 1 minus 2 cosine of x. We would multiply by the derivative of the inside there, but the derivative of the inside is 1. So we can keep that as. Now, where is our derivative undefined or 0? Well, what's great in this case is because it is cosine, we're not worried about an undefined. So let's set it equal to 0 and solve. Because many of you are not going to be able to do this in your head, so you want to show that algebra there. So we're going to add 1 to both sides and divide by -2. So we're looking at where cosine of x is -2. And we're looking from the interval of 0 to 2 pi. And we find that, oh, and this should be negative, sorry. Let me do that again. Subtract 1, divide by -2 is a negative over negative, which is a positive. Whew, there we go. Sorry, guys. Doing my algebra incorrect. Okay, so where is cosine of x 1/2? It is 1/2 at pi over 3 and 5 pi over 3. All right, so now we do our sine ray of f prime. Put this in order, pi over 3, 5 pi over 3. I'm going to do this quite quickly. I'm not going to do the stuff out here because it's our normal stuff. It becomes, oh, hold on. You know what we need to do? Because we have a boundary here, we also have to include the boundary. All right. All right. Now, with this idea right here, I don't have to worry about these sides, okay? But when I have my negative, positive, positive, negative, negative, positive, there's one more thing that you might recognize right here. When we think of polynomials or functions in general, we need to think of the order, okay? And 2 cosine is bigger than 1. So when we look at this function, this derivative, I'm actually looking at -2 cosine plus 1, which what would happen there? That makes my function negative. So I have to add my row of negatives. 3 negatives make a negative, positive, negative. Okay, this will come up once in a while. This is something that is going to be something we get used to, but it won't always happen. So we'll learn those tricks when we see it, okay? I like drawing this out. So decreasing, increasing, decreasing. So we have a min and a max. Now I can write my interval. So I'm going to write it over here to leave room. So I have increasing from pi over 3 to 5 pi over 3. Now, because we have endpoints here, we're going to use those endpoints. We're not going to negative infinity and infinity. So that's why we wanted to write the endpoints here. Now, the other thing is, if you look here, the endpoints have parentheses. So we're going to have parentheses around those endpoints. So decreasing goes from 0 to pi over 3. So remember, pi over 3, we're going to have brackets. Are they going to yell at you or mark off points? No. But the 0 has a parentheses. We need that. And the second one is 5 pi over 3 to 2 pi. Okay, we needed those endpoints because it was given to us at the very beginning. Then we need to write our max and our min. So our relative min is at pi over 3, comma, and if we plug pi over 3, the good thing is, guys, if this were no calculator, you could just plug it in as normal, but that would be pi over 3 minus, well, sine of pi over 3 is square root of 3 over 2. Square root of 3 over 2 times 2 is square root of 3. Relative max, we've got that at 5 pi over 3. So we're going to do the same thing. So we get, when we plug it in the original, we get 5 pi over 3. Now in this case, because this would be sine of 5 pi over 3 is a negative square root of 3 over 2. The 2's cancel, but a negative times a negative is a positive square root of 3. And we're done. Not leaving myself much room, am I? All right, number 3. Okay, one thing you always have to keep in mind, domain restrictions. What can't be in the denominator there? It can't be 0. So what makes the denominator 0? Well, x cannot be 0, okay? Now, when we take the derivative, we have to keep in mind that we are doing the quotient rule. So I'm probably going to use all of this down here on this side just to do some of the algebra. So f prime of x equals low times the high, so 4x cubed, minus our high times the low, which is 3, all over our low. The whole thing is squared, so don't forget to put that in parentheses. Now, distribute, multiply, do all that stuff. When we get that out, I get 9x to the 4th minus 9 all over 9x squared. But I see I can actually factor out a 9, right, guys? You guys see that? All right, so if I factor out a 9, okay, I end up with, I'm going to put it over here, x to the 4th minus 1 all over x squared. Let's go with that a little bit further because I want to be able to see my critical numbers, right? Well, this is the difference of squares. So that is x squared plus 1 times x squared minus 1. And you guys see what I'm going to do next? Hopefully you see that there is another difference of squares. So I have x squared plus 1 times x plus 1 times x minus 1. You want to break it down all the way so it's easier to find those zeros, guys. Okay. Let's keep this in mind. We've got critical numbers. Critical numbers is when our f prime is 0 and f prime is undefined. F prime is 0 is when the top equals 0. Well, this binomial here can never be 0 because when we square a number, we're going to get a positive plus a positive is a positive. But we have these two instances where x equals 0. So critical numbers are when x equals -1 and 1. And then we have to say, hey, when is the derivative undefined? Well, look at the denominator. Where is it undefined? It's undefined at 0. Before, when we were reading how to do this, we also had to keep in mind that when doing your Steinway, your domain restrictions are not involved. So we want to be careful here. I want to show you this. So I do not want to say that 0 is a critical number because we're not going to include it. Here's the tricky part. On my sine ray, when I do my sine ray, I'm only going to keep in mind my -1 and my 1, okay? But what I do need to do, so when I do my sine ray, write this, okay, it goes negative, negative, positive, negative, or negative, positive, positive, negative, negative, positive, right? But here's the idea. We do still have to keep in mind that domain restriction, because remember, it can't be that. So you can do something like reminding yourself that it's an asymptote, which means it can never get there. Now, when doing your intervals, this will make more sense. So performing my sine ray, I don't include the domain restriction as another row. So negative times negative is a positive. Negative times a positive is a negative. That means both of these sides are negative, guys. And then a negative, positive times a positive is a positive. Okay. So, excuse me. I want to check something out really quick after this, and then I'll come back to you if I need to. But right here, when you think of our increasing, decreasing, right? Oops, sorry, my pencil's in the way. So we've got increase, decrease, decrease, increase. Okay. So increasing will go from negative infinity to -1 and 1 to infinity. Now here's where your domain restriction comes involved. Is decreasing. We go from -1, but we cannot include 0 since it's an asymptote, guys. So that's why we have to keep it in mind. And then we still decrease on 0 to 1. Okay. That means we have a max here and a min here. So we have a relative min at x equals 1, so 1. And when we plug in 1, I'll do that for you. You get 4/3. And I should put min because m is max also. Relative max is at -1. And when I plug in -1, I get -4/3. All right. Let's go to 4. Okay, 4, we got to get some of those e's in there and ln so we remember critical values. Okay, so let's see, domain restrictions on here. Are there any x values that would not work? No, we're all good. There's nothing in the denominator. There's no holes. There's no jumps. Okay, so next step, derivative. This is the product rule. So first function times the derivative of the second. The derivative of the second is itself, because e is itself, times the derivative of that exponent, which would be a -4x. And then we're going to add, and I'm going to put it down here, guys, because I don't want to run into number 5. The second function times the derivative of the first, which would be -1. Okay, what I'm going to do now is I'm going to simplify that as much as I can so I can see my critical values. So here I get 4x squared times e to the -2x squared minus, because it's times -1, e to the -2x squared. Now again, you might be like, how am I supposed to find the critical values without my calculator? Well, they have something in common, so let's pull that greatest common factor out. We end up with e to the -2x squared times 4x minus 1. You see how I pulled that e to the negative 2x squared out? Okay. Oh, and this is squared. There we go. Now, if you look, this is good. There's nothing that will make this 0 or undefined, but what we have to do is be careful here. You can either solve it algebraically, or this is the difference of squares. So this is also e to the negative 2x squared times 2x plus 1 times 2x minus 1. So e to the negative 2x squared can never be 0 undefined. These two can never be undefined. So our critical numbers, or our critical values, are where they equal 0, and they equal 0 at 1/2 and negative 1/2. Okay, the good thing is when we have two numbers on the number line, negative 1/2, 1/2, I'm just going to do this out for you. It becomes a plus minus plus. So two places where it's increasing, one place where it's decreasing, and we have a max and a min. Okay, so increasing from negative infinity to negative 1/2 and 1/2 to infinity, decreasing from negative 1/2 to 1/2. Whew. And then a max, this is the same thing like we did before, our max and our min, where we know it's 1/2 and negative 1/2. Just plug into the original equation and just keep the 1 and the negative 1/2 there. Don't evaluate it, you don't have to. So I'm running in a room, so I'm not going to do that. Okay, number 5. First of all, any domain restrictions? No, there's no problem. This is a function, continuous function all the way through. So let's do our derivative. We get 3x squared minus 6x plus 3. What I want you guys to see is that we can do a greatest common factor, and then we can factor that out. So I'm going to do that so I save room and I can do this all the way. So it's going to be 3 times x minus 1 times x minus 1, which we write as x minus 1 squared. Now there should be hopefully a light bulb, because remember, when we do a sine ray and it's squared, how many lines do we do for that number? We need to do 2. Okay, so our critical value, our critical number is x equals 1. Okay, so when we do our sine ray, we have x equals 1, but we got to do it twice because it's squared, remember? So negative, positive, and then I have to do 2 rows of it, so negative, positive, which gives me positive, positive. So it is increasing, increasing. Now, since 1 is not a domain restriction, when we do increasing, we can just do negative infinity to infinity, okay? Which means there are no decreasing and there's no relative max or min, and we're done. Okay, let's see. It explains more a little bit about example 5. The function in example 5 is strictly monotonic function, strictly increasing or strictly decreasing. They're called monotonic. Okay, so example 5 illustrates 2 important points. Not every critical number produces relative max or min, so we have to keep that in mind. And then even though the slope at x equals 1 is 0, the function is always increasing, so it's always going up. We're going to be practicing some graphing techniques when we get back. So it's going to be interesting how to sketch an increasing with the slope of 0. All right, let's get some practice.